Hey all you science furs, coming to you from Dragon's Lair East here in sunny Colorado, where the forecast high will be 60 degrees Fahrenheit during what is typically the coldest month of the year. Please forgive me as I am working from a script while also operating the camera and performing demonstrations as I produce a single shot video. Today is Sunday, day of the Fun Day Poppet Show, on February 3rd, 2013, here in the Quantum Physics Science Laboratory of Scorch G. Dragon, where he is exploring the possibilities of utilizing torsion field physics to convert energy from the surrounding environment and convert that energy into the more useful form of electricity. The current project is a device which is basically a motor generator called a dynamo. Constructed from common off-the-shelf materials including non-magnetic stainless steel fasteners, shafts, hubs, and other hardware commonly used in robotics, as well as other materials as simple as acrylic discs, Litz wire, ferrite cores, magnets, and even household items such as these sewing bobbins used to make generator coils and motor coils. And to all those who are interested in science or electrical engineering, I would like to demonstrate something that I find very interesting. Over here we have a coil wound with wire along with a ferrite core and a magnet. And if I test the inductance of this coil, it comes to 0.48 millihenries. Then if I add a ferrite core to increase the efficiency of the coil, the inductance actually comes up simply by dropping a core into that coil. We're now up to 1.23 millihenries. But watch what happens to the inductance of this coil when I add this tiny magnet, which is not moving and is merely in a static condition. I'm going to turn this coil over and stick a magnet to it. And now we're back down to 0.66 millihenries. And this is a static condition. This is a non-moving magnet which has a dramatic effect on the inductance of this coil, which is back down to 0.66 millihenries, while still maintaining the advantages of using a magnetic core in a coil that can be used in a motor or a generator. And over here I do have a very unique motor generator called a molar dynamo. I don't know if Molar is the original inventor, and in fact this desktop version was originally presented on YouTube by a user named Romero UK. And in fact this version, my version, is not even the same design because I have not yet incorporated the ferrite cores or the magnets on the cores, and I'm not even using the same Hall sensor driver circuit he had used, such as represented in this diagram over here. I am currently using what is known as a simplified schoolgirl, or SSG, to run my motor coils, which is this diagram here, which are bifilar wound and connected to this SSG circuit, which is designed to capture back electromagnetic fields and return what is normally wasted energy back into a destination battery. You'll see we've got two batteries here. One is labeled source and the other one is labeled destination. That's right, folks. While this motor is running on one source battery, it is also charging the destination battery. And as you can see, I am currently just running air cores mounted on nylon fasteners. We do have 2 motor coil pairs and 7 generator coil pairs, for a total of 18 coils mounted on stator plates of acrylic. The rotor is merely another disc made from polycarbonate that only has 8 magnets in relation to 9 coil pairs. This results in a rotor that has far less cogging because there's only one magnet lined up with one coil pair at any given time. And even more interesting, all coils fire in just a few degrees of rotation, and here is a paper representation of this. As you can see, starting with the magnet marked with an arrow, this one right here at the top, there's the first magnet marked with an arrow. As this magnet moves from just one coil to the next, all coils are activated. If I simply move that to the very next position, okay, there's that one, that one, that one, and as that comes around, we're actually firing all 8 coils and then suddenly this coil. So as that's spinning, it has a very interesting effect as demonstrated by that paper demonstration. And unlike a conventional AC alternator, the rotor, like that, has all north poles on one side and all south poles on the other side. So I'm going to go back over here to the device and I'm going to start it up. And unlike a conventional, let's see here, when I start this device, which is using a pair of oscillator circuits to drive the motor, it does produce some very interesting singing or chirping noises. In fact, the oscillators start before we even start the rotor spinning, and it'll actually start charging as soon as we connect here. As you can see, destination voltage is already coming up. It's going to come back down as we start driving the motor here. Unlike a conventional motor in an unloaded condition, which normally reduces current draw as its speed increases, this motor actually increases current draw as speed increases. You can see the current draw is always pretty unstable, but it's slowly coming up. We're up to about 700 milliamps there. And the reason it does that is because it is a pulse DC motor, therefore as speed increases there's a higher demand for DC pulses. Now it takes a while for this thing to come up in RPM. This thing normally runs about 2,500 RPM. To the left, the meter is representing the AC output from just 2 of the 7 coil pairs. And as that comes up, the destination battery is charging. The interesting thing about this motor is once we actually put a load on this, if I actually put a load on this, just a small light, RPM starts coming back down, and of course the current over time will start to come back down. As you can see, that current is now dropping. That's right, folks. A motor generator that actually uses less energy when a load is applied. So in conclusion, this is the current early stages of this experiment, which is not using any ferrite cores, which have the effect of increasing coil efficiency, or core magnets, which have the effect of significantly reducing or possibly eliminating the effects of Lenz's law by way of providing a magnetic field in the core that opposes the magnetic field in the rotor. And of course, other advantages can be added to this experiment, such as a more precision motor controller, double bridge rectifiers, frequency matched capacitors, and tuning the system in order to develop a perfectly tuned resonant torsion field system. That is all for now from the Torsion Field Quantum Physics Laboratory of yours truly, Scorch G. Dragon.